Hello and welcome back to Maskey TV. We are going to be doing analytical geometry today and we are going to look at grade 12. Our learning objectives for today are to go over some of the grade 11 and 12 formulae, and then we are going to look at exam type questions which will involve certain concepts such as gradient, the equation of a line, distance, ratio, coordinates, tangents, equation of a circle, and angle of inclination. Let us get started. So a quick look at the formulae is, we're looking at, our first formula is the distance between 2 points. So this formula uses 2 points. We're looking at the points A and point B. I've given you two different variations of this formula. This one is the one that will appear on your formula sheet. All you do to this one to get this one is to square both sides to get rid of that square root there. As you can see, we have AB squared, but it is using distance formula where we have point A to point B. So we're looking at a line segment A to B. All right, the next formula is your midpoint of a line segment. So you're looking at halfway between 2 points, the midpoint. And how do we use midpoint formula? If we have 2 points, A and B, we simply find the two x-coordinates of the endpoints, we add them together and we divide by 2 to give us the x-coordinate of our midpoint. And then the two y-coordinates of our endpoints, we add together, divide by 2 to give us the y-coordinate of our midpoint. The next thing is the gradient of a line. The gradient of a line, if we have 2 points on a line, we can get the gradient by finding the change in y over the change in x. So we simply take the 2 points and we find the change in the y coordinates, the two different y coordinates, and then divide it by the change in the two x coordinates. Then we are going to look at the inclination of a line. That's your angle of inclination from a horizontal in an anti-clockwise direction to the line. The angle of inclination, the formula that you will see on your formula sheet is tan theta equals m, m being the gradient of that line. And then obviously the second step would be when we're finding that angle, we will have it look like this on our calculator and we'll sub that gradient in there. All right, the next one we have an equation of a line, and there are two formulas here. They both appear on your formula sheet. This one is called the point slope formula, where we have a point, that's your x1, your y1, and a slope. Your slope is your gradient. The slope is your m value here. So you would sub your point in, and you would sub your slope in, and then you would simplify to get your equation of a line. The other one that you know and love is simply y equals mx plus c, where you have your m is your gradient and c is your y-intercept. Then we have the equation of a circle, and that is something we did in grade 12, and we have x minus a squared, where a is the x-coordinate of your center, and we have plus y minus b all squared, where b is the y-coordinate of your center, and that is equal to r squared, not r squared. The last thing I just want to put on our board here is parallel and perpendicular lines. So how do we know we have parallel lines? When the gradient of the line 1, so m1 equals the gradient of the second line m2. So when the gradients are equal, we will have parallel lines. How do we know we have perpendicular lines? When the two gradients of the two different lines, when you multiply them, you will get a result of -1. So that is when we'll have perpendicular lines. Okay, we're now going to get stuck into an exam type question. The question I have on the board for you is a DBE paper. We are looking at paper 2, 2024, and we are looking at question 3, the start of your analytical geometry. We have in the diagram below triangle ACD. Let's have a look at what's going on there. ACD, that's our triangle. It tells us that it has vertices, the points on the triangle A. We don't know what the coordinates of A is. It tells us that D is the point 3 and -9, and C is the point -9 and 0, where A is a point in the second quadrant. Remember, we work out quadrants in an anti-clockwise direction, so this is quadrant 1, 2, 3, and 4. So A is in our second quadrant. And then they also tell us that B lies on DC. We can see B is lying on the line DC over here, B being the point -1 and K. We don't know what that Y coordinate of B is. Okay, let's go through the very first question, and that is 3.1. I'm just going to make it a little bit bigger. There we go. So 3.1, the first question says, calculate the gradient of DC. Now we have the coordinates of D, and we have the coordinates of C. Let's go back and let's write down that formula. So to work out the gradient, M of DC, all right, we are working out 3.1. M of DC, that is going to be, now we are going to take the difference between the two Y coordinates. What I'm going to do actually is going to make it easier. Let's see if I can put on my board here. Ooh. All right, so what I'm going to do is I'm going to write above D and C, I'm going to write x1, y1, x2, y2. So I'm telling myself this is my first coordinate point, and that's my second coordinate point. I'm going to write the formula here. We're going to say y2 minus y1 all over x2 minus x1. And now I simply have to go and look for y2, which is 0. So I'll have 0. y1, which is -9. And whenever we put a negative into a formula, don't forget to put it into brackets, because it's minus -9, which essentially becomes +9. Then I look for x2, which is -9 over there. And I have x1, which is 3. So on top I have +9. And at the bottom, I have -9 minus 3, which will give me -12. And then I'm going to simplify. Let me just quickly, there we go. So 9 over -12, we're going to simplify. 3 can go into 9, it goes into 9 3 times. And 3 can go into 12, it goes into 12 4 times. So my answer there is -3/4. And let's just say therefore, our 3 dots means therefore, MDC, the gradient of DC, equals -3/4. All right, let's go to the next question. The next question asks us to determine the equation of DC in the form y equals mx plus c. So let's just quickly write down, what do we need to find when we are looking for an equation? We know we need to find m, which is the gradient of that line, and we would also need to find c. So if I can find m and c, I would have found the equation in the form of y equals mx plus c. We know that the x and y's represent all the points on that line. So all we need to find is the gradient and the y-intercept, which is your c value. So how do we do that? Well, let's have a look here. We are looking for the equation of DC. We already found the gradient of DC. The gradient of DC is -3/4. And now we simply just need to find the c value. So if I want to find an unknown and I only have one unknown in my equation, then all I do is I sub in a point. So let's write our equation. We have y equals -3/4x, and we have plus c, because we know that the gradient of DC is already -3/4. So all we need to find is c. So what I'm going to do is I'm simply going to substitute a point on that line, and I can choose any one of these points, C or D, because I have both the X and the Y for both of them. I'm going to choose C, so I'm going to sub in C, which is -9 and 0. When I sub C in, remember your first is your X and then your second coordinate is your Y. So Y is going to be 0, and I'm going to have -3/4 times, I'm going to put in brackets, -9 plus C. Right, -3/4 times -9, that gives me -27/4. Wait, not negative. Negative times a negative gives me a positive plus C. Right, now we need to find C. So what are we going to do? We're going to get rid of the positive 27 on that side, and we're going to subtract 27 on both sides. So I'm going to subtract 27 over 4 rather, on both sides. So minus 27 over 4. I'm going to just write it over there. Right, 0 minus 27 over 4 is simply minus 27 over 4. That's going to equal to C. 0 minus 27 over 4 is negative 27 over 4. And on that side, the negative 27 over 4 cancels with the positive 27 over 4. So C is equal to that. So now that we have M and C, we can rewrite our equation. Therefore, y is equal to negative 3 over 4x. And our C value is minus 27 over 4. Right, okay. The next question, let's go. 3.3 asks us to show that k is equal to negative 6. Now, if we are asked to prove or if we are asked to show, it means that that is the case. K is in fact equal to negative 6. But something that's very important, don't use it to prove it. We cannot use k equals negative 6. Can't go subbing it in and saying, yes, it works out. We have to use other maths, other types of calculations to find k equals negative 6. So let's pretend we didn't know what k was and we need to work out k. Well, what do we know about this straight line over here? We actually have the equation of DC, right? We have the equation of DC. The equation of DC is y equals negative 3 over 4x minus 27 over 4. So if we have the equation and we have a point, right, we have a point, this point over here, which is b, negative 1 and k, and we have the x coordinate of that point. If we want to find the y coordinate, we simply sub in the x coordinate into the equation to find its corresponding y coordinate. So what I'm going to do now is I'm going to sub in, answering 3.3, I'm going to sub x equals negative 1 into the equation to find the corresponding y coordinate, because b is a point on the line DC, so it should satisfy that equation. When I plug in negative 1, I should be able to work out the y value when x is negative 1. All right, let's sub that in. So negative 3 over 4 times negative 1 will give me positive 3 over 4. So 3 over 4 minus 27 over 4. And we are working out the y coordinate over here. And if we put that in our calculator, we will get negative 6. So 3 over 4 minus 27 over 4 should give us a negative 6. Right, so y equals negative 6. And what have we actually answered the question? Not quite, because we said y equals negative 6, and they told us to prove that k equals negative 6. But remember, the y coordinate of point B is equal to k. So we just have to say, therefore, k is equal to negative 6, because k is the y coordinate of point B. So we have a question. The question was, why did I use point C instead of point B? Right, point B over here. Well, the reason why I couldn't use point B was because I did not have the y coordinate of point B, right? I needed to have both the x and the y coordinate to sub it into this equation. Here in 3.2, I needed to sub into an x and a y to solve for C. So I needed to have both the x and the y coordinate. However, I could have used the coordinates D, 3 and negative 9 instead of C. You would have come to the same answer. All right. Please, people, if you have any questions, ask on the chat. Let us know what you're thinking. Answer the questions if you can. Let's see what's going on. Do the maths with us. Take out a pen and paper and let's work through these questions, grade 12. All right. Next question, 3.4. Calculate the length of DC. So now we have point C and D, DC, right? This line over here. And they want us to find the length of this line over here. Right, remember, to find length, we simply use the distance formula, because the distance is in fact the length of a line segment from one point to another point. So we're going to find the distance of DC. And I'm going to write the formula, which is square root, and it is simply just x2 minus, I almost wrote x2 minus y1 It's x2 minus x1, the difference between the two x values squared, plus y2 minus y1 squared. That's the formula, that's it. So that's how we can remember. It is on your formula sheet if you do forget, so you can check over there. So what I'm going to do is, as you can see, I've already got x1, y1, x2, y2. I'm simply going to sub it in now because we are still working with point D and point C. So x2 is -9, and x1 is 3. Right, and then y2 is 0, and y1 is -9. Remember, when we sub that -9 in brackets, because we've got a minus a -9, and that essentially is going to become a positive. All right, let's simplify inside our brackets. Brackets first, BEDMAS or BODMAS if you prefer, always applies in every math situation. So inside this bracket first, and then we will apply our exponent. So -9 minus 3, that's going to give me -12. It's still in brackets, grade 12s, because we are squaring this whole bracket. It's still in brackets. And then we've got 0 minus -9, which essentially becomes +9. And we want to square that. And we should all know our squares of 12 and 9. Remember, because it's in brackets, -12 squared becomes positive 144. And 9 squared becomes 81. Right. 144 plus 81. And these are nice numbers. It comes to 225. And let's just double check that quickly. 144. Plus 81 on my calculator, 225. And the square root of 225 is 15. Right, I didn't check that. Trusting myself here. Yes, it is. Okay, 3.4. So that means that the distance of DC is 15 units. They didn't give us any measurements of units, so we're going to say, therefore, DC equals 15, and we're going to write there units. All right, let's see what we have next to do for us. All right, the last question here is 3.5. And 3.5 asks us to calculate the ratio of dB over DC. Right, so we already have the length of DC, so we simply need the length of dB. Now remember, we had to work out B. We were told to prove that K equals -6. So let's say you couldn't work out K previously, but you were told it is equal to -6, so you could use that one there. However, if you do have an answer to a previous question, use your previous answer in your next question. Okay, so we are going to just write, we're going to fill in that this is -1 and -6. -1 and -6. And now we're going to find the length of dB. We already have the length of DC. They want us to find the ratio of dB to DC. Right, so let's go. The length of dB, the square root of, and I'm going to, my formula is there above, I'm going to go straight to it. Ooh, I'm not going to write the formula again. I'm going to go straight to it using the points here. So remember, dB, it is the change in the x coordinates and the change in the y coordinates. So I'm going to go x, it's 3 minus -1, so it will be 3 minus -1 was the coordinate there, and then I've got -9 minus -6, -9 minus -6. The change in the x coordinates and the change in the y coordinates, right? 3 plus 1, because that becomes +1, is 4. Let's just keep it in brackets. -9, and that becomes +6. -9 plus 6 is -3. And we are going to square that. So we've got 4 squared, which is 16. And then we've got -3. And remember, we're squaring -3, so it's going to become +9. The square root of 16 plus 9, that is the square root of 25, which we all know is 5. So dB is equal to 5 units. Right, so we've got dB over DC, which is equal to 5 over 15. Remember, we got DC was 15, so this is my ratio now, 5 over 15. And we can also simplify that. 5 can go into 5 once, right? So 5 can go into both the numerator and the denominator. 5 goes into 15 3 times. So the ratio is actually 1:3. Just remember the way they wrote it here, they said dB over DC, they wrote it as a fraction. They could have also written it rather like this, dB to DC. You will answer it the way they asked it. So if they asked it like this, you would then write 1:3 like that. Okay, right. That is the last question here. We're just going to go through where you're getting your marks quickly. So if you want to have a look at the screen, you will see 3.1. We are getting our marks over here. We are getting correct substitution. So it's simply subbing in. This is the second way. So I'm just going to work with this one over here. Subbing in and then answer, right? So subbing in and then answer over there, right? So subbing in and then answer. And then over here, our equation, subbing in again and answer. So subbing in so we're subbing any one of the points in. So we'll show that your sub and then your answer. Over here, this one was just 1 mark, right? Finding K or proving K, and the mark was simply just for the substitution. So anywhere where you substitute, could have done a few methods, you're getting the mark already. The next one here, again, substitution, and then answer, and then here getting first dB, and then getting your ratio in simplified form, right? So that is where you're getting your marks over there. I'm going to take a short break. I'm going to leave you guys with the next question, which is question 4, also from the NSC 2024. We'll be back shortly. Go through it, grab a pen, and go through it on your own. Welcome back, grade 12s. Let's go through question 4. So as you can see, this one has an equation of a circle type questions. The previous one that we had was more grade 11 type questions, right? Let's make this a bit bigger, and then we can look at this diagram and the write-up. So it's very important to read the write-up before we get stuck into the questions. So in the diagram, we have M, which is the center of the circle. So they've given us the center, which is 1 and 3. And then it tells us the circle cuts the x-axis at N, which is over there. We can see it. It also says that ST is a tangent. So we have a tangent, ST over here. A tangent is a straight line that touches our circle at one point, and it's touching our circle at point P, 3, and 9. We have point R over here, which is D and 1. We don't know what the x-coordinate of that point is. We are told, however, that D is greater than 0. We can also kind of see that because it is on this side, so your x-coordinate should be greater than 0. And L lies on the circle, which is over here. O and V are the x-intercepts of PL and RL respectively. So O is the x-intercept of PL and V is the x-intercept of LR. All right, let's get started in those questions. So the first one says, write down the coordinates of L. So let's have a look at this. I hope you guys have gone through it. If you're struggling with this, let's go through it together, right? So we are looking at coordinates of L. L is over here, and what I can see over here is I have PML, which we should all know is the diameter because it is a chord that goes through the center of the circle. And we are told that M is the center, which means that if we have a center point here, P is an end point and so is L. So if I want to find the end point and I have the center point and another end point, I can use midpoint formula to find it. So I'm just going to write midpoint formula. I'm going to write down what the formula is. So 4.1, the midpoint formula is in fact the coordinates of a midpoint. Remember, it is the sum of the two x coordinates, x1 plus x2, of the endpoints. So the endpoints would be L and would be P. So those are your endpoints. So it's the x here. I'm going to call it x1. Or rather, let's call it x2, right? x2 and y2. This is your endpoints, and we're going to call this x1 and y1. That's our first point. This is our second endpoint, right? Our midpoint formula is made up of x1 plus x2 of our endpoints divided by 2 will give us the x coordinate of our midpoint. And then for the y, it's y1 plus y2 divided by 2, which will give us the y coordinate of our midpoint. Now we already know our midpoint, and it is also labeled M, which is nice for us. M, which is 1 and 3, right? Which means that this is equal to 1. That gives us 1. This over here, the two y coordinates of the endpoints divided by 2 must give us 3. So what we're going to do is we're going to separate these because I know that x1 plus x2 divided by 2 must give me 1. And I'm just going to put on this side over here as well, right? y1 plus y2 over 2 must give me 3. So I know that this gives me the x coordinate of my midpoint and this gives me the y coordinate of my midpoint. We don't know both endpoints, but we do know one of them. So we know x1 is 3. So I'm going to sub it in there. I know that x1 is 3 and I don't know what x2 is. I don't know what x2 is, right? But we know that x1 is 3, so that means 3 plus the second x coordinate divided by 2 must equal to 1. So what we're going to do now is we are going to multiply both sides by 2, right? So I'm going to times by 2 here, times by 2, and then that is going to cancel. I'm going to have 1 times 2, which is 2 on my right-hand side, and I'm left with 3 plus my second x coordinate, which means I can now solve for my second x coordinate. How? I'm going to subtract 3 on both sides, right? That will fall away, and I've got x2 equals 2 minus 3, which is negative 1. So my x2, which is the x coordinate of L, should be negative 1. Right, let's work out our y coordinates on this side over here. So we know that our first y coordinate of our endpoint is 9. We know that it is 9. So we're going to sub it in. That's 9. And we don't know the second y coordinate of our endpoint. So we're going to call that y2. Remember, we don't know what our endpoint here is. But we know that this plus that one divided by 2 gives me 3. So divided by 2 gives me 3. So what we're going to do, the same thing we did for the x, is we're going to multiply by 2 on both sides, times by 2, right? And therefore the 2's will fall away on our left-hand side, and we'll be left with 9 plus y2. Our second y coordinate is equal to 6. Right, now what we're going to do is to get rid of that 9, we're going to subtract 9 on both sides. And the 9 is going to fall away here, and we're going to have y2 equals 6 minus 9 gives me negative 3. And so, therefore, the x coordinate of L is negative 1. The y coordinate of L is negative 3. So, therefore, L is the point negative 1 and negative 3. We just simply used midpoint formula to find the end point of that All right, so now let us go to the next question. We now know that L is -1 and -3. Going to the very next question, which is determine the equation of the tangent ST to the circle at P. So we're looking for the equation of the tangent ST. I'm just going to highlight ST. So that is this line over here, right? Now, let's talk about tangents. What do we know about tangents and circles? Can we think of anything about tangents and circles? Because what I'm seeing here is I'm seeing the radius is MP, right? And I should know that the radius is always perpendicular to the tangent at the point of contact. So I'm going to use that now to get the gradient of this radius. And if I can get the gradient of this, I should be able to get the gradient of my tangent. Why do I need the gradient of my tangent? Remember what we said earlier on, whenever we are trying to find an equation of a line, whenever we are trying to find the equation of a line, we need to find, this is 4.2, y equals mx plus c. We need to find the m and the c of that line. So we are looking for the gradient of the tangent and the y-intercept of the tangent. Now, we know already a way to find the gradient, so let's go for it. So we're looking for the gradient of the radius. The gradient of the radius is, and to work that out, we are going to use a y2 minus y1 over x2 minus x1. Right, so y2 minus y1 over x2 minus x1. And we're looking at points P and M. And what I like to always do is I like to put an y2, oops, let's just rewrite that, x2, y2, x1, y1, and then we just simply plot it into our formula. So y2 is going to be 9, y1 is 3, x2 is 3, and x1 is 1. So it's 9 minus 3, which is 6, and 3 minus 1 is 4. So, 3 minus 1 is 2, right? 3 minus 1 is 2, and 6 divided by 2 will give me 3. So that means that the gradient of my radius, I'm writing mrad, but you could have written, you can write it as mp, because it actually is from M to point P, right? It is the gradient of the radius. Now that I have the gradient of the radius, the gradient of ST, which is my tangent, should be M tan should equal to, remember it's the opposite sign, so it'll be negative because that's a positive, and you swap the numerator and denominator. So if this is 3 over 1, then my gradient of my tangent will be 1 over 3. Why? Remember back when we looked at the formulas, if they are perpendicular, then when you multiply them, so 3 over 1 times negative 1 over 3 must give me a negative 1. So that's how you work out if we have two perpendicular lines. And we can only say this is our gradient of a tangent because the radius is perpendicular to the tangent, right? Or tan perpendicular to rad, right? Let's rather write it the way you guys would remember it. Tan perpendicular to rad. Tangent perpendicular to your radius. Okay, now that we have the gradient of our tangent, remember, in order to find C, we need to sub in a point on that line, like we did earlier on. And I can see we only have one point on this line ST, which is point P, so I'm going to sub in point P. I'm going to sub point P into the equation with the gradient negative a third. 3 and 9. Right, so that's my x and that's my y. I'm going to sub it into the formula y equals negative a third x plus c. So I'm going to sub in x's place negative 1 over 3 times 3, and in y's place 9. Right, so I've subbed in my point 3 and 9 into my equation, and now all I have to do is work out c. So let's simplify. A negative a third times 3, well, 1 over 3 times 3, that's simply 1. So this will give me negative 1. And what we're going to do now is we are going to add 1 on both sides to get rid of the negative 1 on the right-hand side rather. So I've got c equals, I didn't add my 1 on my left-hand side, so I've got 9 plus 1 equals c, which is then 10. So c is equal to 10. The m is equal to negative 1 over 3. Therefore, the equation of my tangent is negative 1 over 3x plus 10. Let's look at the next question. So we have our equation of our tangent line, and our next question is, show that the equation of the circle with center M is, and they're giving it to us not in standard form, not x minus a all squared plus y minus b all squared equals r squared. They've given it in a different way. However, we know the center of the circle, right? So they're asking us to show this is the right answer, right? They want us to show that it is equal to this. So what do we know about the equation of the circle? We know that the center is 1 and 3. So I'm simply going to sub it in to my formula. I'm just going to write it there. So this is your formula. This is our A is going to be the x coordinate of the center, and B is our y coordinate of the center. So x minus 1 would be our A value, and y minus 3 would be our B value. Right, so we've got our equation. The only thing we don't have here is r squared. So we'd still need to work out the radius, and not only would we work out the radius, we want to work out the radius squared. So I think I'm just going to put this up a little and we'll come back to it. So what I'm going to do is I'm going to work out the radius squared quickly. So my radius is I can take any two points from the center to the circumference. I'm going to work with these two. I think let's do these two, M and L. So I need to find the distance from M to L. So M, L will equal, and we're working with distance formula, but remember I showed you two different variations. So I'm going to do the one where we square both sides. So I'm not going to have the square root. Okay, I'll show you what I mean by that. So I've got ML, which is my radius, by the way. That's my radius, right? I'm going to show you the square root of, it's x2 minus x1 squared plus y2 minus y1 squared. What I'm going to do now is I'm going to square both sides, and that will get rid of the square root. So it's actually ML, which is r. I'm going to write it as radius squared, equals, and the square root that will fall away now, x2 minus x1 squared plus y2 minus y1 squared. We want the r squared. Remember, we want the r squared for our equation over there. So let's get r squared. So I'm going to use ML. Let's do it. So M, we've got 1 minus negative 1 squared plus, and then L, we've got 3 minus negative 3, okay, squared. All right, so 1 plus 1 is 2, 2 squared is 4. I hope it's okay that I'm going a little bit faster. So 1 plus 1, and that's 2. That we square, we get 4. Right, 3, and then we're adding here. Let's just put that bracket so you can see. 3, that minus negative 3 becomes positive 3. 3 plus 3 is 9. 9 squared will give me 81. Okay, so let's just double check. 3, yes, that's right. So 4 plus 81, that will give me 85. All right, so my r squared is equal to 85. All right, so that is my radius squared, and we're going to sub it into my formula. I just want to double check. So it's 1 minus negative 1. We're using L. That gives me 1 plus 1. Yes, so that is your 2. 2 squared is 4. And then 3 minus negative 3. That will give me a 6. Sorry. So 3 minus negative 3. I'm not sure where I got 9 from. So 3 minus negative 3 will give me 6. 6 squared is actually 36, right? Okay. Right, so 4 plus 36 is in fact 40, right? Okay, so r squared is equal to 40. Now, if we had put that into our equation, we would have not come to this answer. We would have known we made a mistake, and we would have had to find our mistake. And I just remember, what did I do? I wanted r squared. I didn't want r. So what I did was I squared both sides to get rid of my square root. I took that whole square root here and I squared that side, and I squared my left hand side to get r squared. Why did I want r squared? Remember, we want r squared because r squared is what we want in our equation over here. So I'm going to put 40 over there. Okay, I can see that I'm not going to be able to do this question, adjust this over here. So I'm going to take this and do it underneath over there. I hope that's okay. I'm just going to rewrite it. We're going to simplify. Why? Because we want to get that, right? So let us simplify. All right, so I've got x minus 1 squared plus y minus 3 squared is equal to 40. So what we're going to do is we're going to square out this bracket and square out that bracket. I'm going to use our methods we should know when we're squaring a binomial. It's the square of the first term, which is x squared. The first term times the second term doubled. So that becomes x times -1 is negative x. Doubled is negative 2x. And we square our second term, which is positive 1. And then the same goes for this, so it'll become y squared, square of the first term, y times -3 is negative 3y, double negative 6y. And then we square out, negative 3 becomes positive 9. And we don't forget we've got our 40 over there. Right, now we are going to simplify. So we've got, we don't really have much like terms here besides the whole numbers over there. So I've got x squared. I'm going to see if I can write it the way they've written it, plus y squared. And then I've got minus 2x. And I've got positive 1 plus 9. And I also know I'm going to take the 40 to the left-hand side by subtracting 40 on both sides. I'm just going to write minus 40 here and minus 40 there. So that means I have 1 plus 9 is 10, minus 40 is going to give me, and I can see it there, your minus 30. Right, so I've got negative 6y there, bring it down, minus 30 equals 0. And I have what's on my right-hand side, x squared, y squared, minus 2x, minus 6y, minus 30 is equal to 0. Okay, let's see what we have next. So the next question asks us to show that D equals 7. I think we are just going to go and have a look at the way that they answered these questions, because I am running out of time here. And as you can see, I've got all the answers here. We will have a look at how they have done it. So they asked D equals 7. So what you had to do with D is D was a point. If we have a look here, D was a point here on the equation of the circles, on the circle. So all you had to do was to find D equals 7 was to sub 1 in y, right? You could have subbed it in this way, right? Or you could have subbed it in to this one over here. So you sub in y and you solve for x. So that is how you found a D over there. I think I'm going to stop here because we are running out of time. But remember, you can go to the DBE website and you can download the 2024 papers, work through it on your own and go through all the questions in the papers. You are gearing up for the exams right now. It is important for you to go through all of the, or as many exams as possible. I suggest next week we are going to go through paper 1. We are going to work through from the 20th to the 24th of October. We are working through paper 1, and just a reminder about our book, Crack the Maths Code, which it's so thick because it has so much things in here, so many things for you to unlock all of the maths. And remember that as you gear for your paper, get ready for your paper, as you're working through questions, make sure that you go through your formula, you understand your formula as we did earlier, knowing how the formulas work and when to use what formula. For next week, we'll be going through paper 1, and the week after that, we'll be working through paper 2. If you want to know what we'll be doing, please subscribe and like Maskey TV so you can get those updates to find out what are we going to be doing next week. And also, if you're having any questions and you have WhatsApp, then go on the WhatsApp line on 072 091 0388. And I hope to see you again soon and hope to see you next week. All the best, grade 12s.
And now we enter our next exciting chapter with the launch of Maskeyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.